So the question here is to find out the neural network that represents exclusive or XOR. So let's start by getting the perceptrons for and OR. So for AND, let's have two features x1, x2. They can take on values 0 and 1. So you can see this as y is equal to x1 and x2. So here is x1 is 0, x2 is 0, so x1 and x2 is also 0. Here x1 is 1, x2 is 0, so 0 and 1 is also 0. So the same thing happens here, and only 1 and 1 is 1. Let's repeat the same thing for OR. Draw this again. x1, x2. 0, all 0 is 0. 0 or 1 is 1. 1 or 0 is 1, and 1 or 1 is also 1. So the last one, XOR, x1, x2, 0 here and here. So 1, XOR 1 is 0, and the other two are 1s. So from these, we can see that we can train a linear perceptron on OR, look like this, and one on AND, looking like this. But we cannot train anything here that's linear because this is not linearly separable. So the trick to construct the network is to have another one, not AND. So let's repeat this x1, x2, and just flip this. So the 1 becomes 0, and the zeros become 1, and then we can have this perceptron train here. So it's kind of confusing. Let's draw the vector, perpendicular vector to this line to get the weights. So the next thing to do is to say that these two will have an output, say O1 and O2. And let's put these O1, O2 into this AND perceptron. So this becomes O1 and this is O2. And let's see what the outputs will be. So the combination of these three, the output of this whole thing, so the output of this AND combined with OR and not AND is, let's draw this, x1, x2. So we start here. So when it's 0, 0, 0 gets input here and input here. So we get O1 is equal to 0, O2 is equal to 1. And then get that point, O1 is 0, O2 is 1. So we are here. So the whole thing would output this 0 here. So we get 0 here. Next, let's try the 1, 1 thing here. So x1 is 1, x2 is 1. So the first perceptron would output 0. The second perceptron would output 1. And then we would combine to get 1, 0, which is this point. So the output is also 0 here. So it's kind of promising. Then the next thing, let's figure out this. This is x1 is 0, x2 is 1. So it's this one and this one, 1 and 1. So it becomes this point. This point is 1. So the output is actually 1 here. So the last one should be symmetric. Let's still do that. So use another color, this and this, 1 and 1. So the output of the second layer would be 1 as well. So this is 1. So basically the output of this combination, which is what we call a neural network, is exactly the same as the output of this XOR operator. So that's how it's constructed.